So, hello everyone. Today we are solving problem jump game. So you are given an integer array norms. You initially position at array's first index and each element at given in the array represents your maximum jump length at that position. Return true if you can reach last index or false otherwise. So basically we are given an array and at each index we are given the maximum length we can take jump. For example, we are initially at 0th index and nums of 0 is equal to 2, so we can take maximum jump of length 2. What this means is either we can take jump of length 1 or length 2. If we take jump of length 2, we will end up at index 3. At index 2. At index 2, we can take maximum of length 1. So we take jump and we reach to the index 3. At index 3, we can again take jump of 1. So we reach at index 4. There is another way. We can take jump of length 1. Now at index 1 we have 3 options. Either take 1, 2 or 3 length jump. If we take jump of length 3, we will end up at last index. So this is another solution. So basically we have to just return true if we can reach last index or not. Let's take the second example. Initially we are at index 0. Here we can take a jump of maximum length 3. If we take of length 3, we will end up at index 3, which is 0. So from here we cannot move further. If we take off length 2, we are here at index 2, and again we take a jump of size 1, we will again get stuck here. If we take off length 1, we are here at index 1. We can either take 1 or 2. No matter which path we follow, we end up at this index and we stuck. So we are never able to reach the last index. So here we are returning false. So how we can solve the problem? We can take intuition that from any given index we can go to maximum of I plus nums of I length. We can reach any index between I plus 1 to I plus nums of I. So we will maintain a variable, let's say maximum distance. Let's suppose we are at index 0. We can go to maximum distance as 0 plus 2, which is 2. So we will be here index 2. Let's suppose after that we are at here 3. So what is the maximum distance we can cover from origin? Means from 0. 1 plus 3. 1 plus 3, which is 4. And we can see we can come till here, which is last index. We can return true. From this index, what is the maximum distance we can cover? 2 plus 1. So from this index we can reach maximum here. Now from the third index we can reach the maximum of fourth index. Now let's come to the next example. From here we can maximum reach to this third index. Again from here we can maximum to third index, and here also we can reach to the third index. So we can cover maximum distance of length 3, and we have to reach at 4. So there is no possible way that we can reach to the distance of 4, so we can return false. So whatever we discuss, let's try to code it out. Let's check if first element itself is 0, if nums of 0 is equal to 0 and nums dot size is greater than 1, we can never be able to move forward from the first index itself, so we can directly return false here. Let's take a variable int max length or max distance is equal to 0, and now we go for each index. For int I is equal to 0, I less than nums dot size I plus plus. We will check if this index is reachable at first place or not. How we can check? If I is greater than maximum distance, we can cover. So it is definitely obvious that we cannot reach this index, so we will return false. Else what we will do is maximum distance we can cover will be max of max distance and I plus nums of I. I plus nums I basically denotes the distance from origin. If any place at any index I plus nums of I value will be equal to nums of size minus 1, basically greater than or equal to nums dot size minus 1, we can easily say it is reachable and we will return true. We can have an early exit also, but we are not doing here. So let's talk about space and time complexity. We are not using any extra space, so space complexity will the space complexity will be big O of 1, and we are just iterating over array, so it will be order of n. So let's try to submit out. Yes, it is working completely fine. So this is it. Thank you.